So, hello everyone. So, let's start with today's problem. Today's problem is quite easy, again marked easy. So, we're gonna solve this problem. And before starting with the video, if you're new to the channel, make sure hit to the subscribe button and make sure hit to the like button because we make such more awesome content regarding DSA, tech, and AI. So, let's get started with the problem. So, what the problem says, maximum number of words you can type. Okay, this seems like again a real life problem. LeetCode becoming very good. There is a malfunctioning keyboard where some letter keys do not work. Okay, it happens, right? All other keys on the keyboard works properly fine. So basically you have a keyboard and then some keys do not work, some keys work fine. Given a string text of words, uh, separated by a single space, no trailing or leading spaces. That's very, very important thing. This will be important for edge cases. So what they are saying is, let's say there is a sentence. So there is no extra spaces in the starting and there is no extra spaces in the ending. So we don't need to worry about okay when to stop. Even when the last character is there, there will be the last character is there. There is no extra space after that. So yeah, this is very important. We'll see why it is important. And a string of broken letters of distinct letter types. Also, they also mentioned distinct that are broken. Return the number of words in the text you can fully type using this keyboard. Okay. 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 So what does this problem is saying? So basically you are writing particular text, you have particular text, and then what do you want to do? Very simple. That you want to type as many words as possible, but some keys are broken. So you typed, but it won't work, right? That means eventually the word what you want to write didn't type properly. Right. So you will discard those words. So the remaining words you will consider it. So you want to consider what are the words you wrote completely. Okay. So by seeing this, what comes to your mind first? Uh, by seeing this, what comes to my mind is you have a text. I just want to split into the words because we have to split into the word and just check each word whether it is completely satisfying the properties or not, whether any letter is broken or not. Like this is my thought process. I hope this also align with your thought process also. So what is my strategy? I have a text. I somehow divide it into words. So this is a very common strategy that you divide your text into the words and then check each word, broken or not, and then just gonna add up to your answer, to your answer, right? Now, how are you gonna check whether a particular, let's say you have a particular word that it's valid or not. So, right, you can create a frequency map or hash map and store these characters so that quickly retrieval you can check, okay, oh, this character is already broken, so you cannot make it. So, what you can do is you can store all these characters in a map, or you can say this is 26 size array as well the map. It's a implementation thing, whatever you want. So you can do that. And then what you gonna do? And how you gonna split the words? This is a very standard technique that you started with the string initially empty. Okay. You started with a string initially empty, and then you gonna iterate in the our original string text. And now there are two possible scenarios, right? Text of I equals to space you get. That means you found you just completed a word, just completed a word. You have to just check the word that you just completed, and then you have to start a new word. Now from text I plus one, start a new word, start a new word, right? So what you gonna do? So you gonna if it is this, so you gonna check. You write a check function to check the previous or whatever you have calculated, and then if it is not the case, Else, what you gonna do? You just add your text I to your A. That will constitute your word, right? So you're gonna run a for loop. What you gonna do? If you will check if it is this, you're gonna stop. Oh, this is my word. I have just completed. Let me just check whether this word is correct or not, broken or not. And if not, then again, obviously, we'll start with A equals to empty, and that's all. That's all, right? And then if it is not the case, then we just keep adding A to our text of I. So this is how our algorithm work. We write a check function as well. I already explained how do you write a check function. Just write a map, store the characters of broken characters in that map, and then gonna check each character one by one whether it is present in our map or not, right? So let me just show you the implementation quickly. It's very simple, not very difficult. So you write a check function, got a string, you got a map, and then what you're gonna do? You just traverse each character by character, and whether you find this character into this map, that means your word is broken. Word is broken. We are actually finding word should not be broken. Okay. So if not any false returns, so we return true at the end. Fine. And then we initialize our map. We store each character in your map. It is all distinct, so you can say one also, but yeah, it doesn't matter. Then this step is important that we write a, and then what you're gonna do? We're gonna iterate on the text. If we find a empty space, that means our one word is completed, like just completed. We're gonna check our a, and we will pass a map. And if it is satisfying, it is becoming true. That means it is a valid word. We just return count plus plus. Else, and also we just set a to again a empty string because our new word we're gonna start. Elsewise, we just keep adding to our text of I, right? So let's say it's like I am a boy, right? So what are you gonna do? A will become I. In the next step, this space will come. We'll check for A, and then A will again become empty. Then A will become A. Then oh, then will go next, and M. Oh, it's not empty. So we'll add up M, and then again go space. Oh, it is empty. Now we'll check this M. And this is how it's gonna look like. So I hope you got the entire intuition. One edge case is remaining, that when you traverse the entire string, right? You're gonna check again and again, but for the last word, you have to write separately. Why? Because there is no again space here, right? So when you go until the end, your A comprises of this, but there is no another thing to break, right? That how you gonna check it? So your A will become at the end boy, and that's all. You have to check this as well, right? Because there is no separator now. So you have to check the last thing. So this edge case you should consider, and they already specified in the question that there is nothing trailing spaces, so you don't need to worry about any other cases because it would happen, right? You have some extra spaces in the end that might constitute A as well. So you have to think about how to deal with that, but you don't need to worry about that. There's no extra space in the starting also, ending also. So just worry about this edge case. It's very important. And yeah, so I hope you understood the question. I just want to make sure that each of you understood these basic questions and build up something really cool. So stay tuned for the further videos, right?